Okay. Problem number 1. You have a low temperature, you have a high temperature. Those are not too bad to find. So write down the high temperature is 70 degrees Fahrenheit. The low temperature is 55 degrees Fahrenheit. If you know the low and the high, then you can find the midline temperature. And you can find it by finding their average. So the average is add them together and divide by how many there are. There are 2 temperatures. And what number does this give us? And you can use a calculator. Somebody tell me, what number does this give us? Oh, I should open my chat box. Online, anybody have it? 62.5. Good. So I want you to just notice that with filling in the information, you've got the high, the low, and the midline, and those should be not as bad to find. Then you're looking for times, and now let's go further. Midnight is when we're at a low temperature. If we let midnight be times 0, then one of the times I'm at the low temperature is times 0. The daily high temperature occurs at noon, so it's simplifying the temperature, making this a little bit easier to work with. And so if that's my high temperature time, then that's 12 hours after midnight. How do I find a time when I'm at my midline based on knowing when I hit a high and when I hit a low? So I'm going to plot those points. At time 0, I'm at 55. At time 12, I am at 70. There we go. So what time, give me a time when I'm going to hit my midline, given that we've got a low at time 0 and then a high 12 hours later. I have to hit my midline halfway through, right? Because it's as you go back and forth between the high and the low, it goes through the midline halfway through every single time. So what is a time when I'm at my midline? Six hours, right? Now, based on that information, and let me plot that midline point about there. Now, based on this, can you figure out a second time for each of these?
Like a second midline one could be at 18.
Right. And then, so it goes low, midline, high, midline 6 later, which there's 18.
Then it's low at 24.
Yep, you got it. low at 24. Then it's going to go back to the midline, and then it's going to go back to the low. The high. Now, if you look at it, it takes 24 hours to go from the low temperature to the next time you have a low temperature. That means that to go from the time I'm at a high temperature to the next time I'm at a high temperature, I can add that same distance. So the time between a high and a high is the same as the time between a low and a low. So 12 plus 24 gets me to 36, which goes off grid. And I just wanted you to find 2 times with each because that's enough for you to get a nice graph going. And so you draw that. I'm doing a mediocre job at drawing, but from there, we're going to write an equation, and we're using the cosine function. Now, cosine begins a cycle at a high point, but it could also start a cycle at a low point. If we decide to start the cycle at time 0, it's starting at a low point, and that means that the graph has to be flipped upside down. That means my A is going to be negative a number. The vertical numbers tend to be easier to find. But if I decide to start my time at 0, that just made things a lot easier to deal with. That means that my C is 0. And that C is just letting you know basically when a cycle begins for the cosine graph that is negative. To find, actually, do we already know D? What is D always?
Midline, correct?
Yep, it's always the midline. So D is 62.5. A is positive or negative the amplitude. We already know it's negative, so now we just need the amplitude. And the amplitude is the distance from the midline to the low point, as well as the distance from the midline to the high point. And what is that distance? If you needed to, you could use a calculator because the midline is 62.5, and you can subtract 55 from that. And what number does that give you? What is it? You guys can use your calculators if you want. 62.5 minus 55.
7.5.
Thank you. 7.5. And now realize the only thing we haven't found at this point is B. And if I want to find B, a formula I can use, and you're allowed notes on the test, is whatever the period is of that graph. The formula is the normal length of a cosine cycle divided by whatever that b number is. So the period that I see on the graph itself, this has a 24-hour cycle. I have a period of 24 hours. I'm going to multiply both sides by 24, or sorry, by b. And then I'm going to divide both sides by 24. And that reduces to and you are now ready to write the answer. Whoops. I was looking at the wrong place. Okay. Then number 2, we have a paddle wheel. And this problem could be made a little bit easier if we draw what this could look like. So we've got a paddle wheel and we're really thinking about it as a circle. And we're looking at a point on the paddle wheel blade. So basically we've got the little blades coming out of the paddle wheel. I'm trying to draw, forgive me. Yeah. Anyway, we've got some point on one of the blades and that paddle wheel is turning. Now, we are told that its distance d from the water's surface is a sinusoidal function. So we've got a water surface somewhere in here. Maybe it's there, maybe it's there. We need a little more information to be able to say where that water is at, but it should be that the paddle wheel is in the water. And actually, where should the water be if the paddle wheel is going to work properly? Where is it normally at? If you think of a steamboat, you can always Google steamboat and look up images, and you'll probably see that. Okay, I'm going to erase this. And so D is distance above the ground. So if my point is at this level, then that's D right there. Okay. Now, let's let time kind of flow out the window for a little bit and not worry about time, but focus on what are the high and low values going on. Those are easier to find. And I see highest is 16 feet above the water's surface. That's my high number. I am also told the wheel's diameter is 18 feet. So I'm going to draw another circle. Here's the water level. And I've got a center. I am told that this distance is 16 feet, and the diameter is 18 feet. So actually, I drew that in the wrong spot, didn't I? So if this distance is 18 feet, then I'm actually looking at the surface of water being about there. So what does that mean is my midline point? Do you see that the midline point is -2? Yeah. Diameter is 18, highest point 16. Ah, oh, no. Okay, so I've got, this is 16 feet. This is 18 feet. And so that means that the center of my circle is -2 feet. So it's under the surface based on those measurements. Maybe I should look up a picture of it. What? Thank you. Thank you. It was pointed out to me 18's diameter, not radius. Okay. Read the problem, teacher. Read the problem. Diameter is 18. That's this distance. And that means the lowest point is -2. What does that make the midline? And the midline is always the location of the center of that turning wheel. And with a diameter of 18, then the radius is 9. So this distance is 9. This distance is 9. That makes the center 7. Ah, the band's playing Under the Sea. -2 feet for the midline value, the low value. So I've got that stuck in my head, don't I? I can do this. I can do this. Low is -2. Midline is 7. Okay. So realize that that gives you those vertical distances that you need. The horizontal distances are going to take, or the horizontal pieces are going to take a little bit more. This is now looking at my input is time. So here we go. Stopwatch reads 5 seconds when it is at its highest point. So highest point is 5 seconds in. Then what other information does it give me about time? It gives me 10 seconds. And it tells me that it completes a revolution every 10 seconds. That actually means that the second time it's at its highest point will be 10 seconds later. So I'm dealing with having a period of 10 seconds. if I know when I have the beginning of a cycle and the end of a cycle, my low is going to be halfway through that. What is halfway between 5 and 10? Or what is halfway between 5 and 15? I'm getting very distracted by the band now. 10 seconds is halfway between, so I will hit my low halfway between my two highs. And then with a period of 10 seconds, add 10 to that, and I'll get a second time for when it's at its low. Then if I look at these numbers that I have, halfway between a high and a low, I hit my midline. So halfway between 5 and 10 is 7.5. We're going to hit the midline again halfway from 10 to 15. And that's going to be 12.5. And if you want a third time, halfway between 15 and 20 would give me 17.5. So any two of those three numbers works. Now let's plot these points. We have the point 516. So 516. Then we have 15, 16. And that will allow me to see one full cycle. At time 10, I am at -2. At time 20, I'm at -2. At time 7.5, I am at my midline of, where is it, 7? I need to circle it. Ding. And then at time 12.5, midline again. I'm going to draw a graph. And I can draw further if I want, but that gives me at least one full cycle. For writing an equation, we're going to want to write a cosine equation. With a cosine equation, I want to look at when am I at a highest or lowest point. If I choose a time when I'm at my highest point, then I will have my A being a positive number. And that time is 5 seconds in. My time that I begin my cosine cycle is my C. D is the midline. A is the amplitude. Do you remember that the amplitude is the diameter of, or sorry, not diameter. My gosh, I'm just messing up on this diameter radius business. It's the radius of the circle. The radius of the circle is going to give me that amplitude. And the radius of my circle is 9. And that is the distance from the midline to the high, as well as the midline to the low. The only number I need now is my B. And to find B, I want to look at what is the actual period of this graph. And I already found that that was 10 seconds. I want to set that number equal to 2 pi divided by B, the length of a full cycle divided by the number we multiply by. So I'm going to multiply B over to the left. and divide by 10. And that reduces to pi over 5. Now I can get you started a little bit on the next two problems if you are really having a hard time and you're stuck. I should have put D equals. I'm not going to put any numbers down. I'm just going to point things out to you. We are told the average high tide is 10 feet. And we are told the level of the water at high tide exceeds the level at low tide by 10 feet. So in other words, low tide is 0 feet. So those are some really important pieces of information there, but I'm not going to tell you where they go. Now it says that the tide comes in and goes out every 24.4 hours. And then it's telling us at time t equals 0 hours, the tide is highest. At time 24.4 hours, the tide is at its highest again. And so from there, see if you can finish this, do the best you can, if you haven't turned your homework in yet. Let's look at number 4. Number 4 is a little bit more complicated because we've got two different distances instead of a distance and a time. And let's make sure we're clear on what is what. You're riding a bicycle. One of the distances that is being brought up is where your foot is located, basically where the pedal wheel is above the ground, above the pavement. The other thing we have is the horizontal distance that the bike has traveled. Now, if you think about a bicycle moving along, what moves first? Your foot moves first. And that creates a distance above the pavement. Understand that that is what the input axis is referring to. This is the distance of the pedal to the pavement. Oh wait, I think I just said that backward, didn't I? When we're dealing with our sinusoidal graphs, this is what I need to point out. When I'm dealing with the sinusoidal graphs, the vertical is the thing going up and down. So what is continuing to go up and down and up and down? That's your distance of the pedal to the pavement. And then this is just a straight shot of distance that you have traveled. So sometimes when you're reading word problems, you do have to read them a couple of times and fix things. Know that when you're dealing with anything that is sinusoidal, the issue you're looking for is what is it that's going back and forth? that has to represent the y-axis. So with that sorted, then I'm going to leave you with this problem and see if you can figure it out from there. Okay, I will stop recording.